Hello, I'm Ed Freeman. I've been doing data science for about 30 years now, since the mid 90s. The field of data science, well, it's had a lot of different names: machine learning, data mining, but for 30 years, the fundamentals have basically stayed the same, and that's what I want to talk about: how to actually do this stuff. I've had a kind of mental picture that I call CRISP of the basic structure of data science projects. And that's what I want to talk about here. I want to start with the idea of CRISP-DM and then expand on it. What CRISP-DM is: cross-industry standard process for data mining. It takes a data mining data science project and breaks it down into chunks: understanding the business, understanding the data, preparing the data, doing the modeling, evaluating the modeling, and then deployment. And I want to keep these chunks, but I want to work with the interrelationships between the chunks. Now, first off, I want to start talking about software development. And not completely, about 90%. You've got the same or similar chunks: business, data, writing the software, evaluation, doing QA, deploying, but ideally they flow one into the next in a cycle. Now, what I found really for data science is CRISP-DM is fairly nicely laid out, but what really happens is a lot messier. Every single part can influence every other part. Let me give you two stories from my career. The first story was working with a bank and a deposit portfolio that was losing a lot of money. In doing basic data analysis, I found out that there are some people that were growing their balances, not shrinking or leaving. And we found out that these people are actually very rate insensitive. They don't care about the rate. So what this meant, they had an intervention in the portfolio of increasing the interest rate. They did not have to increase it for people growing their balances, saved the bank a ton of money. So what that meant was the data understanding changed the business understanding, completely changed the data preparation and modeling and evaluation. A second story, I was working with an insurance company, and their business understanding was they wanted to address attrition. Well, we were doing the project, and the modeling was just very, very difficult. So the models were just not performing up to what we wanted. Well, what I found out at the end, rate changes were having no effect on attrition. And then what we found out is that was because they hadn't changed rate for 10 years. The insurance company had identified the big driver of attrition, changing rates, didn't do that, and so functionally whacked out the top decile of attrition. Now, what this meant is the evaluation stage should radically change the business understanding stage. The business understanding should not be attrition, but rather uh, bringing in new customers. They got attrition handled. There's also something interesting I found out in the data understanding phase. They had customer age, and their customer base was steadily getting older. Now, in one sense, this is good. Older people are more stable, less likely to get into accidents, good customers, until they stop driving and they're not. This company was about to have a big problem with customers aging out that they didn't realize. So again, this is the project completely radically changing the business understanding of what the business has. So now I want to take this and want to get some more lessons for doing data science projects from this. First off, the people in the project need to be able to speak to and understand all parts of the project. In software development, it's pretty easy to be siloed. That doesn't work very well here. Now, every part of the project needs to be as simple as possible. Making any one part more complex will make all the other parts complex as well. Now, there's also a lot of pressure to make every part as complicated as possible. For instance, to use the most sophisticated modeling techniques you can. There's a big difference here between doing papers and doing projects. For papers, you get published if you make things complicated, so you've got something to write about. For projects, you're successful if you keep things simple. Now, from my stories, if exploratory data analysis isn't a critical part of your project, the team is missing out on a huge chance to add value. Again, there's a difference here between papers and projects. EDA is pretty minimal for papers. EDA by itself is valuable for projects. And lastly, I want to compare these two charts. Soft dev, data science. If a team tries to do data science the way they do soft dev, they're going to fail. They may accidentally get lucky, but odds are they're going to fail. So that's what I have for this week. The kind of glorious complexity of data science projects, and that all parts have to be aware of all the other parts. And I'll talk more about how to do this better when I start talking about the Agile Manifesto and applying it to data science. That's my next video. Talk to you then. Bye.